In this video, we are going to talk about what quotient rule is. Quotient rule chechi. Now, quotient rule says, and it came to solve, quotient means fraction. So it came to solve functions that are in fraction form. For example, if you have, where did it come from? So if you have y is equal to u out of v. Now this is the kind where u is a function of x and also v is a function of x. So to differentiate such, to find the dy by dx of this, we use what we call chain rule. So chain rule says that, if we go slowly to know where it came from, if we have a small change effected in y, that is why we say the change in y plus y effected is the same as this one comes as a result of getting the change in u out of the change obtained in v, like this. So changes are actually typically differentiation. Differentiation simply means changes in the variables. That change, that small change in the variables. Now, if we go further, I can take this the other side. So we shall have a change. We want to know how it came about. So we have change in y is equal to u plus change in u out of v plus change in v. I want you to stick with me and understand well what quotient rule is, and then the examples that we are going to do, and towards the end of the video, I'll drop for you the trial question where you're going to try these questions out, and you see that you have understood also quotient rule and it will not disturb you anymore. So we have this. So when you have this, so our delta y is actually equal to u plus delta u out of v plus delta v minus u is y is u out of v. That is it. So if you haven't subscribed, please consider subscribing. Subscribe, it means a lot for me. Now if you continue, if you look at this, we can get the LCM. You can get the LCM. So our delta y is equal to LCM is going to be v into v plus v. Now, after knowing where it comes from, you'll never ever have to cram quotient rule. So this v we shall have v into u plus delta u minus u into v plus delta v. If we have that, if you allow me to draw a line here, so we have that. Now if we go further, we can simply see that here we can expand. So I have delta y is equal to, when you expand, we shall have uv, this time that, plus v delta u minus uv minus u delta v out of v into v plus delta v. So if you clearly see, this can cancel with this. So when they cancel, we remain with delta y is equal to v delta u minus u delta v out of v into v plus delta v. So delta v is change in v. Now, if we divide throughout everything by delta x, so we shall have delta y out of delta x is equal to dividing throughout. So when we divide it throughout, we can have v delta u minus u delta v out of v into v plus delta v, but we have divided it through by delta x. Now dividing through by delta x, it means everything is going to acquire that. We shall have delta y out of delta x equal to v delta u out of delta x minus u delta v out of delta x. So it's the same. Then everything out of v into v minus a plus delta v. So this is the same as this. We have just wanted to divide it throughout on each individual such that it makes sense. So come and say as delta x tends to 0, as it is tending to 0, delta y out of delta x becomes dy by dx, and delta u out of delta x also becomes du dx, and also delta v out of delta x also becomes dv dx. So finally our dy by dx becomes v du dx minus u dv dx out of v square. Where do we get v square? When we substitute here 0, we shall remain with v into v, which ends up being v square. Why are we substituting in 0? That as delta x tends to 0, delta v also becomes 0. That's why we put a 0 there. So end up having, now this is what we call the product, the quotient rule. The quotient rule. So this is how it comes about. Now let us see our first example. So our example, find dy by dx of y is equal to, so we have x squared plus 1 out of x plus 1 everything squared. So we have something like that. We have something like this. So what do we do first? If you allow me to try and divide here. So what do we do first? We come and say, who is our u? Who is our v? So remember, y has to be u v for quotient rule. So our u is what is up. So our u is x squared plus 1. And then our v is x plus 1 everything squared. Now, since here we don't say let, because it's a defined thing, it's a standard thing, it's interchangeable, you can't interchange it. So like saying you can let what is up to be your v and then what is down to be your u. That's wrong. So we don't let because it is already a standard thing. We normally let when we are in the product rule because product is commutative. Okay, so when we differentiate our du dx, here is 2x, and then our dv dx is actually 2. Now this is the simple, we use chain rule to differentiate such a thing. We use chain rule. So we covered the video about chain rule. I'm going to link it in the description so you can go and look through it. So you see what we call simplified chain rule. So here you drop the power, leave whatever is in the bracket alone, reduce the power by 1, differentiate what is in the bracket, you get 1. So this is 2 into x plus 1. That is our final expression. Now it is always better to state the quotient rule. So our dy by dx is v du dx minus u dv dx everything out of v square. Now we substitute in accordingly. Our dy by dx is equal to we substitute in v is x plus 1. This work is so cheap work, so easy things. You just need to master the fundamentals. So du dx is 2x minus u. U is x squared plus 1 times dv dx is this guy, 2 into x plus 1. Then everything over v square, who is our v square, is x plus 1, everything is squared. Then when we square it again, we end up having x plus 1 power 4. Now, if you look clearly here, we have a common factor. We have a common factor, and that common factor, there is 2, and then there is x plus 1. So we pull out a common factor, so we shall have our dy by dx equal to, pull out a common factor, we shall have 2 x plus 1. So into, we shall remain with, into, we shall have, here we are remaining with x into x plus 1, and then minus what? Minus x squared plus 1. So we have that. So simplifying this, we shall have 2 into x plus 1, but into, this is x squared, but there is over, over our x plus 1, everything to power 4. So one of them will go and we remain with, so this is x squared plus x, and then minus x squared minus 1, but everything out of x plus 1 but power we haven't. So let us first put it as 4. Here we showed it, here we had put. So they still go, no problem. So we have 2 into, simplify, the x squares go, so remain with the x minus 1 out of x plus 1 power 3. This is our dy by dx. So our dy by dx is 2 into x minus 1 out of x plus 1 power 3. Now, this is our first case. Our first case, the purpose is, if you look at it, there it has normal powers. Now, let us look at another example where the powers are fraction powers, or the powers are different. So let us look at our next example. So our next example, so example 2, differentiate, what are we differentiating? X minus 1 squared out of square root of x, the power has changed. This is what I was saying. So the power is now a fraction power. So let us look at this. If you allow me to divide here. So first of all, we come and say this. So here you have to let your y. So let your y equal to x minus 1 squared out of. This one is always better when you write it as x power half. So remember, quotient rule says you shall have u out of a v. So our u here is x minus 1 square, and then our v is x to power a half. So when we differentiate this, du dx using quotient, using chain rule. Chain rule says drop the power, if whatever is in the bracket alone, reduce the power by 1, you remain with 1 times the derivative of what is inside, which is 1. So this is 2x minus 1. So we continue. When you differentiate dv with respect to x, you'll have a half x to power negative a half. So when you reduce a half minus 1, you'll get negative a half. Now substituting it back in our quotient rule. So quotient rule tells us that if you have dy, so we know it very well now. So we substitute back, we shall have our v is x to power half times the derivative du dx is 2 into x minus 1, then minus our u is x minus 1 square, then our dvdx is a half x to power negative a half, but everything out of x out of v square. Now when we square x to power half, we end up having x. Okay, so if you look at here, we have a common factor. That common factor 1 is x minus 1, and also x to power negative a half is common. So you say we shall have x to power negative a half into x minus 1. So what are we remaining with inside? We are remaining with inside, we shall have 2x, then minus a half into x minus 1, and then everything all over x. So this x power negative a half will go down, so we have it as x minus 1 into, when you get the LCM inside, which is 2, you end up having 4x minus x plus 1, but everything, we shall have x times x to power half. The half that was this negative goes down, so this ends up being x minus 1 into, we have 3x plus 1, out of this 2 goes down, and then we have it as x to power 3 out of 2. So this is our dy by dx. So our dy by dx becomes x minus 1 into 3x plus 1 out of 2, x to power 3 out of 2. Yeah, so this is how you battle this number and you clear it. Your trial question. Trial. I want you to find dy by dx. Find dy by dx of what now? The dy by dx you are going to find is x out of x plus 1. Don't forget to subscribe if you haven't subscribed. Click the bell icon such that you receive any video that I upload. Turn on the notification such that you receive the video that I upload. We meet in the next. Thank you.